So this will be free response question 2004, Form B, question number 4. It should be the second one in your section 4.3 packet. So the figure above shows the graph of f prime. So things that we have to remember. We want to make sure that we know that this is f prime of x. On the closed interval, so it's closed on this interval. Closed interval, that's going to be important. We now know that since the derivative is defined, it's differentiable on that closed interval. We know that IVT works, we know that EVT works, and we know that MBT works. So how did I know that? They just told me closed interval. I can see that f prime of x exists everywhere because the graph has no discontinuity. What that means is that f of x must have been continuous. So I have continuous, I have closed, and because the derivative exists everywhere, I have differentiable. So now I know all three theorems work. The graph of f prime has a horizontal tangent at x equal to 1 and x equal to 3. The function is twice differentiable, f of 2 equals 6. Okay, so part A, find the x-coordinate of each point of inflection on the graph, give your reason. So point of inflection means I probably need a second derivative sign chart. So we'll use this line right here. And I know that because I have f prime and I'm going to go to the second derivative, I'm going to be looking at slope because I'm taking one derivative. If it was the same function, we would be doing y values. If it was two derivatives later, we would look at concavity. So if I'm going to look at slope, remember they said that there's a horizontal tangent at x equal to 1, and they said there's a horizontal tangent at x equal to 3. The slope before is positive because the graph goes up. The slope in between is negative because the graph decreases, and the slope is positive in the end because it goes up. Let's see, so your points of inflection occur at x equal to 1 and x equal to 3 because f double prime of 1 is 0 and f double prime of 3 is 0 and f double prime changes sign at x equal to 1 and x equal to 3. All right, part B. So part B, at what value of x does f attain its absolute minimum on the closed interval? At what value of f does x attain its absolute maximum on the closed interval? So you see how they keep using this closed interval? Well, remember we said EVT works? You're guaranteed. That's how they can tell you that there's absolute. You're guaranteed absolute max and min. So we know that there's an absolute max or min through EVT. Remember that it could actually be the endpoint. So the first thing I want to do is figure out where my possible max and mins are. So what I'm going to do is I'm going to make a sign chart for f prime because I'm given the graph of f prime. So if this is f prime and I want to make f prime sign chart, we're going to look at the y values. So I'm going to start off with any y values where f of x is undefined or 0. Before I do that, I'm actually going to close my domain. So I'm not going to use beyond -1 and 5. So again, first thing I want to do, look for where the y values are 0. So that would be this point here and this point here. So that'd be at 1 and then again at 4. So my y values are 0 there. If I look at this piece, my y values are all negative because it's below the x-axis. If I look at this piece here, my y values are all negative because I'm below the x-axis, and if you notice here, still below the x-axis. That's why we don't have x equal to 3 on the sign chart. And then afterwards, right here, my y values are positive. So there's what I have for my sign chart. Underneath in green, I'm going to actually draw kind of a rough sketch. So we're starting at some point. We're going to go down. We're going to flatten. We're going to keep going down. We're going to flatten, and then we're going to go up. So you can tell by looking at the graph that this point here is a maximum. You can tell by looking at the graph that this part here is a maximum, and that this must be the only minimum we have. So I am going to make a table of values. So at x equal to negative 1, x equal to 4, and x equal to 5, we know that x equal to 4, since it's our only minimum, that must be our absolute minimum. How do we know that? Because f prime of 4 is equal to 0, and f prime changes negative to positive and only minimum. So we know that it must be the absolute. Now here's the problem. We have that x equal to 1 is some type of maximum, and we have x equal to 5 as some type of maximum. That's actually all you guys can say at this point because we haven't learned how to find a y value from the derivative graph. So for part B, you would only be able to figure out the absolute minimum. You would be able to figure out that you have two maximums, but since we can't find the actual y value, you won't be able to say which one's the absolute maximum. So, part C, let g be a function that's defined by xf of x. So remember, we're given the derivative graph here. This I can see as a product. Keep that in mind. Find the equation for the tangent line of the graph at x equal to 2. So tangent line means we need two things. We need, number one, the point at x equal to 2. And then number 2, we're going to end up needing the slope, which we find by getting g prime of 2. So let's start with g of 2. That would be 2 times f of 2. Well, f of 2, let's see, they gave us at the very beginning, is 6. So we really get 12. And if you remember, the f of 2 is 6. So g of 2 is 12. Next thing we need is the slope, g prime of 2. And remember I said that that was a product? So we're going to leave the first alone, which is x, take the derivative of the second term, plus leave the second term alone, times the derivative of the first term, which is 1. To find g prime of 2, you would take 2 multiplied by f prime of 2 plus f of 2. See what we got. We got 2 f prime of 2. Well, if we look up at the graph, at f prime of x, 2 comma negative 1 says that f prime of 2 is negative 1 because we're on the f prime graph. So we got negative 1 here. F of 2 we just found was 6 from the given information. So g primed of 2 actually gives us 4. The equation of the tangent line, remember we make by doing y minus y1 is equal to m times x minus x1. So my point was 2, and I'll rewrite it, 2 comma 12. So my y value is 12. My x value is 2. And then I'm going to put in my slope value, which is 4. And that would be the equation of the tangent line at x equal to 2. At the end here is the answer key, and hopefully my answer matches. And remember, you can leave your answer the way that I did here, which is y minus 12 is equal to 4 times x minus 2. That is exactly the same as what we have here. So I'm going to rewrite this, and you would get full credit for that. I want you to ignore this part here because you guys don't know that symbol yet. But we would have to compare f of negative 1 and f of 5 to figure out which one is the bigger y value. So in terms of points, you would be able to do a total of 7 points for this problem, not 9, because we won't find, oh sorry, I'm incorrect, 8 points, because we wouldn't know which one's the absolute max. So total, 8 points is what you would be able to do.